How's it? I'm Jordan. In this video, I'll be showcasing a Timberborn style pumping and water storage system. I'll be using Blender, Unity, and as my IDE, Visual Studio Code to write my C# code. Okay, so I just want to showcase what would happen in real Timberborn. Okay, so let's just press play. Essentially what would happen is all these pumps would start pumping. They would start filling up a small water tank. Okay, let's just slow it down. As you see now, there's nearly full. Okay, now the building is totally full, and the second one was starting to fill. Let's just get rid of some of that water there, just to show you again. So if we just replay this, right? Anyway, as you see here, these beavers, they pump a bit and they start filling up the next water tank. And they'll continue until there's either no storage or the water runs dry. In my game, there will be a system, so they'll stop. As you see here, they all stop because there's no water storage, so they just pause, as you see here. We just pause quick. As you see, they just stop pumping because there's no way to put all the water. I have the same system in my Unity demonstration I'm going to show you a little later in the video. And also, as they pump, the water level goes down. You can't really see this because the water is being generated as fast as it's going down. But essentially in my game, it's just a flat plane that slowly moves downwards. So essentially, it's just not very realistic water physics at all. And like Timberborn has amazing water physics, by the way. However, my game is just a simple demonstration, just to show you how to get the system working. Essentially, you can have water tanks with a capacity, and we have pumps that pump it. Okay, so enough from Timberborn. Now I'll showcase my version in Unity. Okay, I'm in my Unity version right now. So I'm just going to press play quick. Press play. And as you see, we start pumping. As you see, the water level starts going down slowly but surely. And if we just zoom out quick, okay, if we look here, our water tank is also quite rapidly filling up. Each water tank, like Timberborn, has a capacity of 30 pieces or units of water, let's say. And after a while, it should start completely filling up it. So, as you see, it will just slowly fill up. And if we just wait a bit, I'm actually just going to go exit full mode. I just want to go here. I just want to go duplicate this a few times, just to make it a bit faster. Just to show you quicker. But as you see now, we'll also go 4 times faster, which is pretty cool. And I think this is nearly done. And as you see, it goes over to the next water tank. And to however many water tanks you have, it will fill them up. And when this water tank completely fills up, then the pump should stop because there's no more, where should they put all that water they're pumping? Okay, let's just wait a bit, and they should all fill up, and there we go, and there we go, and they all stop because there's 2 ways that these pumps will stop pumping. Either that all the water storage is completely full, like it is, or that all the water here will be drained. Also, if we just exit full screen mode and go to our small water tank, you can set how much water you want, your maximum water, and your minimum water height, which is essentially how high this water level can be when it's full, and stuff like that. Okay, now I'm just going to take you to a quick time lapse of me in Blender making our models, the pump, some of the dirt blocks, stuff like that. I'll see you there. Okay, so we're in Unity. So as you see, we have some water tanks here. These are small water tanks. They can hold about 30 units of water. As you see, they have water circles in them that can be moved up and down. And essentially they will be chained, and these will be moved up and down in code, which will essentially show you how full they are. Then we have a water pump. As you see here, this green thing is essentially, if we just hide everything else, is essentially our collider. And by the way, so if we just exit full screen mode, if we go to our pump armature, as you see here, if we go models, I have my pump here as a model. Anyway, I have a box collider. These are the positions, by the way. You can copy them down if you want, or you can just eye-view it as I did. Anyway, we have a rigid body on it with is cinematic and to set to true and use gravity to false. And essentially what this does, this collider, by the way, it's not trigger, by the way. This detects where the water is, and if it's in anywhere here, then it can pump. If it isn't, if there's no water in this within this collider, then it can't pump because there's no water there, obviously. Okay, so another thing, let's just go. Okay, let's just exit isolation view. As you see here, we have our water. By the way, this blue is just, I just opened my small water tank and dragged in, I just dragged in my blue, so I just grabbed from there. Anyway, so this is basically our kind of lake, which is our water source where you're going to get your water from. Of course, if you want to make Timberborn properly, this would be like proper water physics, but this is just a basic thing just to get the basics right. Essentially what happens, this detects if it has water in this area, then it starts pumping. Then the pumping, it loops through all our our small water tanks, and the first water tank that it finds that isn't completely full, then if it's not completely full, then it will fill it up a bit more. But if the first one, let's say, or the second one, wherever is totally full, then it'll go over to the next water tank. And if they're all full, then it will just stop pumping because there's no storage to pump. So there's no way for the water units to go. And that's basically the logic for this program. Okay, so the first thing I want to do is just go over to my... Actually, before I do that, I just want to go to animations. I just want to show you something. On my pump, I have an animator. All you do to do that is just drag your animation controller, and essentially that adds it. And on this, I just dragged in my pump. The speed is set to 1, and essentially that's my animation. So if I just press play and show you quick, as you see, it starts pumping. Okay, let's just close it. I'm going to go to my scripts folder that I made, make a new C# script. I'm going to call it water tank. And before I continue also, as you see, I have a tag on my water tank and on my water. And all you do to add a tag is go add tag and just click plus and change it a bit. Okay, so, and then just add it. So what I'm going to do is, before I continue, I'm going to go scripts. So I'm going to go small water tank and add in my script water tank. And whatever size you want it, it doesn't even have to be a small water tank, it can be anything really. As long as it has a water tank tag and script, then it's okay. Anyway, so, and you can set the min and max on the water tank, etc. Anyway, I'll see you in Visual Studio Code, opening our water tank script. Okay, so the first thing I want to do is make 2 public variables. I'm going to have a public int, water count, and that's how much water there is in the tank. I'm going to make that 0. And I'm going to make another public int, and you probably guessed it by now. This is the max water count. Okay, and that I'll just set to 30 because the maximum Timberborn of the small water tank is 30 units of water. Then I'm going to go to a serialized field. I'm going to make this a float, and this is going to be the min water height. And it is a very special number, by the way, 5.36. Okay, F, by the way. And then I'm going to copy this again, and you probably guessed it by now, if it's min, the next one would be max. And it's a bit strange because it's local stuff, but this is going to be 0.6 F. So the max is lower than the min. It's a bit strange, but yeah. Now what I'm going to do is I'm going to make one more variable. This is going to be a private float, and it's going to be height calculation. And this is a very important variable, by the way. Next, we're going to go start. And the height calculation, by the way, essentially what that does is it gets the maximum water height and the maximum water count, and essentially it does some calculating with a bit of math, and essentially it detects how much water it would need, how much height higher the water level must be each water level to get to the max water count and the max height. It's a bit confusing, but yeah. Essentially, height calculation is equal to the minimum water height minus the maximum water height. Okay, and then it is height calculation is equal to the height calculation divided by max water height. Max water count. Max water count, good. Okay, next what we're going to do is I'm going to make a public void, and I'm just going to make this update actually. It's going to change later, make it more efficient, but this is just for now. So it's a bit long, this one. It's going to be transform.getChild, Transform dot get child, because we want to get the child of the water tank, and that child is the water, which we need to move. Dot local position, because you'll get some weird stuff if you just go dot position, and then is equal to new vector 3, and this would be the same thing, transform dot get child dot local position dot x. Okay, then the dot y will be a bit different. It will be minimum water height minus, in brackets by the way, the height calculation times by the water count. And then we go comma, and then dot z at the end. Okay, it's the z axis. And this is essentially all we need to do. So let's just go Unity quick. Okay. And what I'm going to do is select my water tank. Let's just select one of them, and let's say how much water do we want. If we put in, let's say 20, then it'll be quite full. Because if we go scene now, remove. Okay. Looks like we have some error. Okay, I just figured out what I did wrong. You must make this the min water height. Okay, now let's go back to Unity quick, and if we make this 20 again. Okay, and if we press play, let's make it full screen. As you see, it's quite full, and 30 would make it even fuller. Okay, so what we're going to do is we're actually just going to go Visual Studio Code, and we're actually going to not make it update water level, which is a custom function, and it's going to be public, by the way. It needs to be public because we're going to access another script right now. Okay, so what we're going to do is go back to Unity. We're going to go create. We're going to make a C# script, and it's going to be pump. Okay, and once it's done loading, I'll see in Visual Studio Code. So what I'm going to do is I'm going to go public bool, and it's going to be called can pump, and it's going to be false. Next, what we're going to do is we're going to go a private animator. Okay, and we're going to make a private game object array, and this is going to be water tanks. Okay, now just a note, if you're going to make this a proper game, and like me, I'm just doing this just as a video of course, but if you're making a proper game, then what you'd want to do is every time you place a water tank, then you'd want to probably make this a list, and every time you place it, you'd go dot add your object to instantiate it. So I'm sure there's another way, but that's at least the way I would do it. Okay, we're making another private game object. Okay, and this is going to be water. Okay, next we're going to go start, and before I carry on, I just want to say something also. If we go water, then there can only be one object with the tag water in the scene, otherwise it will get confused. Anyway, if we go animator is equal to get component, and essentially we're just going to get our animator component. Okay, remember get component just like that is just going to get the component on this object. Okay, so what we're going to do is we're going to go water tanks is equal to game object. And remember earlier in the video when I said that you need to add tags? Well, this is why. Dot find game objects with tag, and this will be water tank. Okay, next what we're going to do, actually before I do that, I'm actually just want to set water. So water is equal to game object dot find game objects with tag, but this time it won't be find game objects, it will be find game object, and also we'll be finding the water object. Okay. Then we're going to go dot transform. Oh, sorry, no. Anyway, we're going to just leave it like that. Good. Next, I'm going to go on trigger enter. Okay. And that's just every time. Remember on our pump, we have that collider. Well, that's where it's going to collide with. So essentially what we're going to do now is we're going to go if, and by the way, I think I forgot to mention something. Let's just go back to Unity. Ignore the error. If we go back to here, the pump, if we go to our water, I'm not sure if I mentioned it already, but we have a mesh collider on the water. And essentially it has a convex enabled, I say enabled, and is trigger enabled. Now this is very important. Otherwise we won't be able to detect it. Also, we have a rigid body with use gravity disabled and is cinematic enabled. Okay, let's go back to the code. Okay, so let's add some stuff to this if statement. If other dot compare tag, and essentially we're just checking our tag compared to a string we're giving it. Okay, and essentially this just checks between the string and the tag of other, which is by the way a collider. Anyway, what we're going to do is can pump is equal to true. We're going to copy this nearly exactly, but this time we're going to do a different function on trigger exit, not 2D by the way, because unless you're doing a 2D project. Anyway, can pump this time will be false though. Okay, now I'm going to go void. I'm going to go update. Okay, and if you can pump, you can go is equal to true, but there's just a smaller way of doing it. Anyway, if you can pump, then animator dot speed is equal to 1, and we can go else. Then what will happen is we can do the same thing, but this time make animator dot speed equal to 0. Okay, so we're nearly done. All we have to do is go IE numerator. Okay, this is going to be a bit of a long one. We're going to go lower water levels. Okay, and we're going to take in something, transform, and we're going to take in a variable called water. By the way, it's not the water at the top, that's a game object. Anyway, we can go yield, return, new. By the way, IEnumerator lets you use coroutines, and this is what we're doing now. Coroutine, by the way, is just a kind of timer, essentially. Return new, wait for seconds time, real time. And by the way, what value you put in this is essentially how many ticks is it like our water physics update ticks. When we update our water physics, essentially. I'm just going to make it every 3 seconds. Anyway, so in here I'm going to add an if statement. If you can pump, so you can pump still, then we're going to go our water dot position minus equals the new vector 3, and essentially it's going to be 0, comma 0.01 f, and then comma and 0. That's just going to move it downwards slowly but surely every 3 seconds. So before I carry on, I'm just going to test it. But first we actually need to do something. We need to do start coroutine. We're going to call this twice. First, we're going to call it on start. And we're going to go start coroutine, lower water levels, and we're going to give it our water dot position, water dot transform, because we want to give it our transform here. And essentially what we need to do then is, if we just go semicolon, and there's one more thing we need to do is, it doesn't matter if we can pump or not, we're going to call this again on the infinite loop essentially, And we don't have to do water transform because it's already a transform. We're going to use this water. Anyway, if we go Unity quick, okay, and if we press play and zoom in, if we see our water level, as it pumps, it should lower. Oh yeah, I think I know why. We must go to our pump. We must actually add it to our object. So prefabs, pump, and go pump. Good. Okay, now if we press play, every 1, 2, 3, yep, it load. And the same thing again and again, and it will slowly but surely lower. By the way, there's a nice system because the more pumps we add, let's say we just duplicate it a few times, wouldn't look like there are lots of them, but because they're in the same position, but every 3 seconds now it should go down quite drastically low. Anyway, so let's go back to Visual Studio Code quick. What we're going to do is we're going to write a bit more code, and in here we're going to there's the logic where what you must do is we must loop through all our water tanks in the scene. And essentially what we need to do is we need to check all our water tanks, and if it's not full, then we'll just add water count to it and update our water level. But if it's full, then we just go to the next tank and the next and the next until they're all full, and then we'll just pause, eventually, or stop. So what we need to do is we need to make a for loop, and this is going to be essentially every time if the water tanks dot throughout the water tanks dot length, however much that is. And essentially what we're going to do is we're going to go to water tank instead of water tanks is equal to water tanks this time. It's a bit confusing. And that index, okay, and then we're going to get component, and you guessed it, water tank again. Anyway, and that will get the script water tank. Then we're going to do 2 if statements. First one is just if, let's say, it is not full. So if water tank dot water count plus plus, okay, so water count is anything smaller than the water tank dot max water count. Okay, if it's within that bounds, then it will go water tank dot water count plus plus, and then we'll go water tank dot update water level. This is why we needed a public method, or we couldn't see that. And then finally we're just going to break, because we found it and we don't need to carry on with the rest. And we don't want to, because that could add for however many other tanks there that aren't full, and that could be really bad. Next, what I'm going to do is I'm going to go I is equal to our water tanks, okay, dot length, okay, and go dot minus length minus 1, and our water tank dot water count is the same as water tank dot our maximum water count. So that basically means that if all the other tanks have failed and this tank will fail, then what we need to do is we just need to go can pump is equal to false, because you know the tanks to fill up and we're just going to break. And I'll exit it. Okay, so this is our last test we're going to do. Let's see if it works. Okay, let's press play, make it full screen. Okay, it pumps. If we check here also, as you see, it starts pumping. Oh, sorry, wait. Let's just go here quick. Okay, let's make the water count 0 just to make it nice. If we check this, oh, sorry, let's make it full screen. As you see, it slowly but surely pumps. If we just duplicate this a few times, then it should pump a bit faster. No, 4 times, let's say. Anyway, it should pump 4 times faster now. Anyway, let's just check. Oh dear, something went wrong there. Oh, I see what happened. I didn't copy the whole thing. What we need to do is, sorry, okay, it's full screen again. Anyway, now we can just copy these, and now they will go 4 times faster. Okay, sending some weird stuff there, but yeah. Anyway, essentially this will go 3 times faster. Let's say they're a bit misaligned, of course, but yeah. Anyway, once it's full now. Okay, then it starts going to the next tank. And this is just to speed up, by the way. Of course, in the game you'd want to make it so you can merge and stuff like that. But yeah. Anyway, as you see, it's slowly but surely filling up. Okay. And if we just wait a bit. Okay, it's nearly full. Maybe one more last time. And it's full. And they all stopped because they can't pump anymore. It's all full. Okay, this is the end of this episode. Hope you enjoyed it. Bye!